What if a hacker could control every device on your network just by pretending to be your DHCP server? Scary thought, right? In this video, I'll show you how attackers hijack networks using rogue DHCP servers, and more importantly, how Cisco's DHCP Snooping feature can stop them cold. Stick around to the end where I reveal the one simple command that blocks 99% of DHCP attacks. IP addresses can be configured statically or dynamically. Statically, you have to configure the IP address yourself on your computer, router, or switch. In dynamics, this means that we use the DHCP protocol. This is a server that assigns IP addresses to network devices from a pool. A Cisco router can be used as a DHCP server, but in general, Microsoft or Linux servers are used. Now we will see how it works. The PC shown on the left does not have an IP address. On the right, we have a DHCP server with the IP 192.168.11.254. A DHCP pool has been configured on it with an IP range of 192.168.1.1 to 0.50. If you start the PC, it will ask for an IP address by broadcasting a message, DHCP Discover. As the PC has no IP address, it will send the DHCP Discover in broadcast. When the server receives this message, it will respond with a DHCP offer. This is a message that contains an IP address, which the PC will be able to use. The server can also provide a default gateway, the DNS server address, and many other options. After receiving the DHCP offer message, the PC will send a DHCP request message to ask the server if it agrees to use the information contained in the DHCP offer. And finally, the DHCP server will respond with a DHCP ACK message. It can be seen as an acknowledgement of receipt of the PC's request. DHCP snooping. DHCP servers play a vital role in most of today's networks. Most network devices use DHCP to achieve an IP address, a subnet mask, a default gateway, and the IP addresses of the DNS server. In a previous course, we saw how DHCP works. Here we will look at the attacks that use DHCP and two tools to combat these attacks. DHCP snooping that we will detail in this course, and dynamic ARP inspection, DAI, which we'll see in the next course. DHCP snooping concepts. The word snooping literally means spying. DHCP snooping is a technique that allows the switch to be configured to listen for DHCP traffic and stop all malicious packets, which would masquerade as a DHCP. On the diagram, we have a DHCP server that is represented at the top of the topology. At the bottom right, you see a legitimate client who wants to get an IP address. And at the bottom left, we have a malicious PC on which software is installed to run a DHCP server. So, who do you think will respond first to the DHCP Discover message that the customer sends to request their configuration? The real DHCP server, the one at the top? Or is the PC running a fake DHCP server, i.e. the one at the bottom? On large networks, the DHCP server is usually much further away. If an attacker launches a DHCP server in the same subnet where the target is located, then they will likely be the fastest responder to the client's request. If the attack succeeds, then the fake DHCP server could assign the client its own IP address as the default gateway. This is what is known as a man-in-the-middle type of attack, which we have already detailed earlier. Another possible type of attack would be that the fake DHCP sends its own IP address as a DNS server in order to, for example, spoof websites. The malicious PC could even send a lot of DHCP discover messages to the real DHCP in order to make it exhaust all its stock of IP addresses. So how can we stop all these attacks? This is where DHCP snooping comes in. Thanks to it, it is possible to configure the switches so that messages such as DHCP discover and DHCP offer follow a single path. For example, interfaces that connect to clients should never be allowed to send a message such as DHCP offer. They can therefore be tagged as untrusted, which will have the effect of blocking this type of message. Only a configure interface with a trusted tags will be allowed to forward DHCP offer messages. It is even possible to rate limit its interfaces so that the attacker does not send an unlimited number of DHCP discover messages in order to exhaust the DHCP pool. With this type of process, when a Cisco switch receives a DHCP discover, it will transmit it only over authorized interfaces. This prevents fake DHCPs from receiving this type of request first. We will now move on to its configuration. To put it simply, we will base ourselves on this type of topology. The Fast Ethernet 02 interface is connected to the client that wants to obtain an IP address from the DHCP server connected to it on the 03 interface. The attacker, who executes a fake DHCP, positions himself on the 01 interface. We'll see how to stop it. To begin with, it is first necessary to activate the DHCP's monitoring in general with the IP DHCP Snooping command. So, by default, the switch adds option 82 to the DHCP discover before passing it to the DHCP server. Some servers don't like it too much and abandon the package. This is why, if the client no longer obtains an IP address after having enabled the DHCP snooping system, then the No IP DHCP Snooping Information option command must be used. To continue, we will select the VLANs for which we want to use DHCP monitoring with the IP DHCP Snooping command and add the VLAN number. In the example, this is VLAN 1. Once monitoring is enabled, all default interfaces are no longer reliable and therefore no longer allow DHCP messages to pass through. That's why you have to open the interfaces that lead to the real DHCP. In the example, we will connect to the 03 interface and make it do a IP DHCP snooping trust. The word trust means reliable. The 03 interface, which leads directly to the DHCP server, will therefore be seen as a reliable interface to let DHCP messages through. It is also possible to limit the number of DHCP packets that the interface can receive. To do this, you need to use the IP DHCP snooping limit rate command. For the example, I configured it to a maximum of 10 DHCP packets per second for the interface connected to the client. This means that the port will no longer be reliable beyond the limit. The Show IP DHCP Snooping command is used to check the monitoring configuration. It can be seen that option 82 is disabled, that the customer's ware cannot send a DHCP offer and can receive a maximum of 10 DHCP packets per second. Wearing the DHCP is completely reliable, i.e. only it can send messages of the DHCP offer type. And the strikers will not be able to send any. The Show IP DHCP Snooping Binding command is used to track the binding of MAC addresses with IPs. All messages of the DHCP offer type that circulate on an untrusted interface will be deleted. In the example, we can see that the legitimate client has received an IP address from the real DHCP server.